Hey guys, in this video I'm going to be showing you how to solve these linear algebra problems here. So it says find all values of k for which the given augmented matrix corresponds to a consistent linear system. First, for a system to be consistent, we know that it has to have at least one solution. It can have one solution, which would be the unique solution, or it can have more than one solution, and in that case it has to have infinitely many solutions. But either of those conditions means that the system is consistent. Okay, so starting with 19a here, the first thing we want to do is we want to start row reducing. So we can see we already have a 1 in this position here, so that's going to be a leading one up there, and we want to get a 0 in the columns below that, which in this case there's only one column with a 4 in it. Alright, so to do that we can start off by saying 19a, and we can say negative 4 times r1 plus r2 becomes the new r2. Alright, and what that's going to leave us with is 1, 0, k. The first row is going to be the same here. And then below that, we're going to have 8 minus 4k and negative 6. Alright, and that's all the row reducing that we're going to need to do here, because if you look, we have some number here, and then we have negative 6 over here on the solution side. So this number here cannot equal 0. If this were to equal 0, then we would have 0 equals negative 6, and that's not true, so that would mean no solution. Alright, which would be an inconsistent system. So this value here, this 8 minus 4k, that cannot equal 0. So to solve this, we can say 8 minus 4k cannot equal 0. Alright, and solving for k, that's going to leave us with k cannot equal 2, and that's going to be our solution here. Alright, so we can say all vals of k cannot equal 2. Alright, that's going to be our solution for 19a there. Now moving on, I'll leave 19b for you guys to try on your own. I'm going to go to 20a. So something a little different here. We have a 3 in this position where we want to get a leading 1. So starting off row reducing again, what we can do is we can say 1/3 r1 becomes a new r1. And that's going to be our elementary row operation there. Alright, so what that's going to leave us with is 1, negative 4/3, and then k over 3. Then in the bottom here, we're going to have the same row. So negative 6, 8, 5. Alright, after that, what we want to do is we want to get a 0 here in this column below the leading 1. So to make that negative 6 a 0, we can say 6 r1 plus r2 becomes a new r2. Alright, and looking at that, our first row there is going to stay the same. And in our bottom row here, we're going to get a 0. We're going to have another 0 here. Then we're going to have 5 plus 2k. Alright, so looking at this again, we have kind of the same scenario as before. We have some number over here, and then we have a 0 right here. So this 0 cannot equal any number other than 0. Alright? If that were the case, that would leave us with no solutions and an inconsistent system. So we know that this 5 plus 2k here has to equal 0. So solving for k, we're going to get k equals negative 5 over 2. And that's going to be our solution there for this system. Okay, so going back to these problems and looking at what we did was we said, okay, which values of k are going to make this system inconsistent? Alright, and then we solved for those values and we said, okay, these are the values that k cannot equal for the system to be consistent. So we almost did like a reverse thing there. So we said, which values will make the system inconsistent? Everything other than that is what's going to make the system consistent. Okay, so I'll leave 19b and 20b for you guys to try on your own. I'll leave the solutions in the description of the video below. And I hope that you guys enjoyed watching this video. That's going to be it for today. If you did enjoy this video, then check out my channel. I'll have more videos like this coming soon, as well as some other videos that you may enjoy. Thank you for watching.